Okay, cool. So restarting now that we're recording. I guess if we want to go ahead and get started with project updates, I see something's there now. So do you want to go ahead and start?
Yeah, sure. I can. So I just added a quick update for the cluster API provider. Nothing major going on, just continuing to hack away on the cloud provider interface. Starting to run into some challenges from the cluster API side, just based on the way that, kind of where the project is from the cluster API perspective, kind of what changes we might need to make Karpenter work a little better there. So I'm kind of gathering those requirements, but still pushing forward to try and at least get a proof of concept going so we could see how it would work. And I had some questions about logging and kind of instance types and other things. So I wanted to give a shout out to Bryce and Todd and Jonathan for their help in the community channel. So thanks a bunch to you all. But yeah, that's it for me.
Okay, and thanks. And then I see Bryce, you asked like if we should leave Azure Carpenter provider updates as well. I think we've been giving updates for the AWS provider here, so I just gave an update for the CAPI. So I think if you have any updates to give, that would be appropriate.
Yeah,
If
I'm
there's
just
any.
wondering the right format, right? Like, should it be per hot release, like V35 or whatever, right? Like every time we upgrade, or should it be weekly? Because like I did fix a bug, but it's like it won't be released in the managed provider for a while. It'll only be available in self-hosted because we have to roll it out, etc. So let me just think more on the best way to surface those updates.
Okay, yeah, sounds good. I don't think we have any major updates to give at the moment from the AWS side. We did just release both upstream and for the provider V36. Those release notes were called out in the Kubernetes Slack. I don't know if anyone else from AWS wants to give any updates there or if we're good to move on. All right. So if nothing else there, I guess we can start talking about the RFCs. Um, so if we want to start with Bryce, your RFC.
Yeah, so I think we've sort of driven to a stage of consensus here where we've all agreed that the list approach for reasons embedded directly in disruption budgets is probably the best approach. But I've heard that we're still waiting on like a PM review from AWS side. I was wondering like what's the best way to go chase that down? Do I just need to keep pinging uh, I think is Alex, right? Is the PM on the AWS side uh, to get approval on this thing.
So I don't think, I think he should take a look at it, but I don't think it just like generally in the community, considering where this PR lives and like what repository it lives inside of, like I don't think we should arbitrarily block like in a way that is like blocking from the cloud provider side. Like I do think cloud providers should give their input and we should have enough time for everyone to like give
Review.
feedback. But I don't want to necessarily block you. I think everyone on the maintainer team is pretty comfortable with this at this point. So I think we're definitely like, I need to re-review this again. I know Nick is off and he was mainly looking at this, but I think we're pretty comfortable with this change at this point.
Okay, yeah, I figured just like Nick was like, oh, I'd like to have our PM look at it and see if he sees anything crazy before I approve. And I think that's reasonable that the, product facing people should be. I mean, right now, AWS at least is the biggest adopter. Maybe as it grows, you will have less influence or whatever of the project. But if you don't want it in, etc., or or the PM has some objecting opinion, I will totally accept that because you guys are the most widely adopted project. It just makes sense at this
I guess
stage.
it's more of a question of governance model. Like from y'all's side, do you guys have? I mean, obviously you raise the PR, so it's a little different. But in terms of like if we were raising RFC, like I don't think
We would never, right? I mean, not at this stage. There may be some things that like we share and the PM will have an opinion on, but most of the time we're the ones reviewing it, right?
Yep.
So I guess it's our job to raise things to our individual product teams that we think are interesting to them or that they might have criticism for as an engineer.
Yeah, I just don't want this to get pulled out too long just because we have a team blocking it. Just because
I appreciate that. Yeah, yeah. Thank you.
Yeah.
Okay. Was there anything else you wanted to discuss with this RFC, or just wondering about the PM reach out and what needed to be done there?
I think we've discussed enough. There's like
Okay.
300 comments. Yeah, I'm happy with it. I think everyone else is sort of happy with it. Just, trying to close it off before I start new ones, right? I want to pick up some work on extended resources, and I want to make sure I don't just leave things hanging before I jump off to a new tangent, right?
Right. Okay. Yeah. Sounds good then. Okay. Moving on, I guess, talking about extended resources then. You want to talk about this?
Yeah, so Nick and I have been talking a little bit about supporting all the different extended resources. So right now there's a lot of hype for GPU resources, time slicing, and then Garvin has like a really big case with huge pages, and tons of people in the community have been asking about it. So right now I just want to collect all the user stories. Nick started this page, and individual customers can write up this sort of document like Garvin did a great job where he explained his use case and his thoughts of ways it could be solved. I'd like to get the feedback from the community on like what resources we think are most important, which ones we should prioritize for, etc. So right now, we've just created this doc to gather use cases and start to document all of them down in one place. And then after we get a bunch of feedback here, I'll go and I'll write an RFC that encapsulates a solution for all of these different resources, or scope it down, right? Depending on if we need to.
I will add a network bandwidth use case. Thanks for opening this.
Yeah, I'd love if you throw something
Yeah.
in there. Yeah.
Yeah, and I think I saw it. You sent out a link to this in the Karpenter dev chat a while back. Did you also send one out in the normal Karpenter chat?
I did not. I should do that. And it was Nick who started this. He gets full credit. I just kind of picked
Okay.
it. Like I'm going to be driving it forward from now on. Let's see. But I'll share that in the normal Karpenter channel as well. Good call out.
Mhm. Okay. Well, yeah, awesome. I mean, extended resources has definitely been something we've been hearing a lot about for a long time. So I'm excited to see what you guys come up with here.
Yeah.
Okay. Anything else you wanted to add to that, or move on to the next topic?
We can move on. I just wanted to make sure that like I know some of the people like M. Groot, he shows up and he has the good ideas. So I want to see if I could get them captured in the documents. So just figured I'd raise it here, and he can fill it out async, or other people can as well.
Yeah.
All and any ideas are appreciated. Thanks.
Yep, that's good. Yeah, we
Yeah.
mainly just want to be able to schedule pods together to avoid scheduling, co-locating too many pods that consume a lot of network on the same node. And spread constraints aren't really a good option for that, and neither is just like anti-affinity. So having an ephemeral or an extended resource for like the available bandwidth would allow like 3 different pods to request different amounts of network bandwidth than the scheduler allowed, and like would make smart decisions about putting them where and how many could go together. So
Yeah, that makes a lot of sense. Okay.
yeah,
Okay.
but yeah, I'll dock that up.
Appreciate it. Yeah.
Otherwise, I have the next thing. I just want to note that I think all of the open feedback has been addressed for termination grace period on node claims, and I think this is ready for a final review. So hopefully everything's in alignment, but sorry it took so long.
Yeah. So any call outs? I know.
I know Jonathan's been pretty active on this one, so I
Yeah.
assume he'll want to have another look. But
I'll take another look. I had kind of referred you to Jason. I think Jason, you
okay.
about this as well too. Like I'm still trying to take a look at it, but Jason had talked a little bit about like, because Jason is working on some of the tainting work for like marking nodes that meet certain disruption conditions as either prefer no schedule or no schedule entirely. We're still kind of debating this topic.
Yep.
And part of the consideration with that means that like, if you do like a prefer no schedule, you can still have pods that can schedule to it that have a do not disrupt. So you can still get yourself into that. Like even with that
Yeah.
node, statistically speaking, you probably will still not be in a case more often where you have do not disrupt continually scheduling to the same node. But if you have all your pod or all your nodes expiring at once, it's possible that like pods will just keep rescheduling to the same
Yeah.
node. And
No,
then
we're
you necessarily need, yeah.
yeah,
They
I can make a big disclaimer on this PR and that it does not solve the entire problem, because there's still cases where a node would never be able to be disrupted due to either those annotations or like eviction limits being reached. And so that's definitely a separate project or problem that I'm interested in continuing to work on. With
Yeah,
with
I think
Jason.
the point of me calling that, I think the point of me calling that out was mainly that
Mhm.
it, as we were thinking through that idea, I think to your original point, maybe our discussion maybe like a month ago on this was
Mhm.
that like this only solves like once you're manually terminating things. And I think we were debating whether like you should have a like two different grace periods, one grace period that basically says like, okay, I have a disruption condition. Give me a certain amount of grace period before you actually start to terminate me. And then after you start terminating me, there's a separate grace period.
Yep.
I think it's a little bit awkward for a lot of
I
users.
agree. Yeah.
It's like, because like most likely what you're trying to actually say is like, and even in the general case, like you're probably like expiry and maybe drift are like the two best examples, right? Where you're trying to say like, get rid of my node after 14 days, or drift is a little trickier because like once I'm drifted, how long do I wait? But I think
Yeah.
realistically what we're thinking of is like with expiry, you'd say like, get rid of my node gracefully after 7 days. If you're not able to gracefully get rid of my node after 7 days, then wait, some grace period amount of time to fully like force terminate it, which
Yeah.
is akin to what you had originally thought, which was like assuming there's a grace period set, start terminating the node as soon as you get the disruption condition.
Yep.
The three things that need to be in place are obviously that logic to start terminating it immediately, the termination grace period logic for the PR that you've written already. And then the third thing was, I think we want to shift do not disrupt pods, because the original reason we decided to ignore them as part of the drain flow,
Mhm.
we'd originally respected them during the drain flow. So it was like if you deleted the node, do not disrupt would still be just respected until the pod was completely finished. And then at the point that the pod finished, then we could completely delete the node. But then it hung a lot of nodes for a lot of users because
Yep. Because
Yep.
somebody will have a job that takes 3 days or
exactly
a week to run. Yeah.
Yeah, people wanted a way to like force terminate their nodes in like the worst case. So
Yep.
we decided to say, okay, this only applies to the disruption flow and blocking the disruption flow, but it doesn't apply to the drain logic. But I think if we have a grace period generally, then we get around this problem entirely. Because somebody could basically, if they really wanted to, they could update like an annotation on the node or the grace period on the node pool itself to be able to tell the node like, hey, forcibly terminate me like in 0 seconds or something like that.
Yeah, and just full disclosure, I have a hacked implementation right now for like an extra do not consolidate annotation in our clusters. And it because we need the ability to rotate the nodes with like drift changes basically and not have that be blocked. And so that other annotation only blocks consolidation disruption, but not drift disruption. But we are working to basically forbid all use of any of those annotations whatsoever. Because blocking disruption at any like large amount, like at the node level, is just not a good practice. So I'm working with like some of our like Spark teams and stuff that are running big long jobs to have viable alternatives through pre-stop hooks, which are also useful because they cover cases like drift that the do not consolidate annotation wouldn't cover, that just like aren't practical to use for cluster operators. So I'm hoping to share that stuff out in the issue for like the consolidation TTL, like that kind of stuff, as some alternative workarounds that are not Karpenter specific.
Let me see if I followed what you just said. So you're saying that, yeah. So you're basically saying that, were you saying the do not disrupt and do not consolidate annotations at the pod level or at the node level?
They're at the node level because obviously, well, okay, let me take a step back. The annotation is obviously on the pod, but
Yep.
that blocks all disruption of the node. which is problematic because we may be trying to evict other things that don't have that annotation on them that can be safely terminated so that we can actually cycle the node out. Because the goal is ultimately to cycle the node for whatever change it needs or et cetera, whatever. It needs to be disrupted for some reason. So do not disrupt is basically a non-starter for us because we cannot, because it blocks our ability to do like security patches. So if we need to go and like up like the OS, like Ubuntu or whatever we're running is has a problem and we need to rotate it, we just can't with Karpenter if there are any pods that are using that annotation right now. So otherwise we have to go out and manually boot those pods, and that's just ridiculous amount of toil for cluster maintainers. So
Totally makes sense in the current state. I'm just trying to understand long-term state here. So it sounds like you're saying that you would go back to using, or you would go back to allowing your application operators to allow them to like set this annotation, assuming that you had a mechanism to say grace period, you know,
maybe
7 days or something.
In general, I think that using the annotation is not the best path, even if we do update it to work with termination grace period, because it doesn't it blocks every pod on a node from being evicted, not just itself. But I don't know if we updated it. Like I also like don't see how the two would be reconciled like very like cleanly at all. So to an extent. So right now my focus is find alternatives for the things that need it, which are typically job pods, through pre-stop hooks, because that doesn't have anything to do with Karpenter. And then, we just don't use annotations whatsoever. And the only problem left to solve is just eviction.
Doesn't the pre-stop hook still hang you though? I mean, obviously.
So what we're doing with the pre-stop hook is we are working up some examples where you can either use a sidecar or you can build like something like kubectl into the main image of the thing so that the pre-stop hook has access to it. And then that pre-stop hook can be smart enough to know if it was evicted by Karpenter or by a user initiated disruption, and then decide to sleep and delay the termination of the pod, or to just bomb out and let the thing be killed immediately. Yeah, that's a little complicated. So let me know if you have questions about that.
What are the scenarios where you bomb out and you just like terminate immediately?
So hypothetical, one good example, GitLab CI has the ability to just like kill your CI job run through its UI. And what is supposed to happen if you click cancel on the job is that the job should stop immediately, as like a user should be able to just force terminate that job. If you're using a pre-stop hook, if you're protecting your CI jobs from like Karpenter initiated disruption via pre-stop hook, that would also block disruption from the UI. So this is why the differentiation is needed to check what the source of the termination is in order to decide if we're going to actually delay in that pre-stop hook or to just let it go.
So I'm curious, in the case of a Karpenter initiated disruption, is the pre-stop hook in this case just sleeping indefinitely until the pod either gets evicted because of termination grace period or until it finishes?
It depends. In theory, it's sleeping until the work is done. That is the goal. If you are using the sidecar approach, you have to actually have a way to check when the work is done. Unfortunately, Kubernetes doesn't stops updating the container readiness after the pod enters a terminating state. So you can't just check the K8s API to know if the other container is completed or not, because it just doesn't update it anymore. What you can do is you can look for like a shared file so like if like the job finishes and then writes some kind of like, hey, I'm done file that can still be read. They're like an empty dir mount or something from that other process. You can also do like process like namespace sharing. If you want to get like funky and actually like observe the status of the other running process in the neighbor container. You can also, if you are running inside the same container and like your pre-stop hook has access to kubectl inside that main container that you're running in, then you can just sleep indefinitely and the pod will still terminate cleanly, even if you have like a sleep infinity inside the pre-stop hook, because the main container is terminated. K8s will still clean up the pod, even with that infinite sleep.
Okay.
So yeah, we've been playing around with this a bit to understand like all the ins and outs of it.
So I guess I'm still a little confused. What is the
goal?
Is the main? No. I get the goal. I kind of get the goal. You just described. But I'm mainly curious about like why that use case is not met by, I get that it's like a Karpenter specific concept and maybe like long-term upstream the concept. We're already talking with like cluster autoscaler and just generally, and like honestly, the mechanism I think that would be great long-term for something like this do not disrupt taint, which is like a custom mechanism to do basically a single pod disruption budget, more or less. I mean, it's like some form of a blocking mechanism that already exists in Kubernetes.
Yep.
So perhaps there's something like this that gets upstream long term, but I guess what, like if we were to do this kind of thing where you have a Karpenter SH do not disrupt annotation, you can set a grace period on your node pool, and then maybe eventually you could set it on the node claim of the node long term.
Yep.
Like that not meeting your use case for like Karpenter specifically respecting your pod sticking around, but you're still able to like get rid of the pod.
I think it could, yeah. And I'm definitely open to that being extended and then like potentially replacing the stuff that we're playing around with. It's, I mean, there is like the aspect of like, what if we replace Karpenter with something else? Like, I really don't care that much about that. Like, I'm happy to switch implementations whenever that eventuality like it comes. Hopefully never. But no, I'm definitely open to like improvements on those annotations in particular, and our users would be as well. Like right now, the pre-stop hook thing is a bit more complicated than they have the appetite for. So, but there's also limited teams that we're working with this particular problem on. So yeah, in short, yes, I'm very open and interested in improvements to how that works today. And I don't, yeah, as far as it meeting needs or not, I don't see any reason it wouldn't. The main problem with like do not disrupt right now is that it blocks all drift reconciliation. But we also need to delay pods when drift is occurring as well. So that's kind of the sticker, is that we want to delay as much as the cluster administrators are okay with, for both types of disruption, or for all general types of disruption, but without blocking indefinitely.
I'm wondering, would that delay typically be different than what you would configure termination grace period to? I'm kind of
No. I think that termination grace period is designed to be that configurable delay.
Okay, because I'm kind of thinking we had discussed this briefly in the disruption TTL issue.
Yeah.
In the scenario where you just consider, hey, do not disrupt pods, don't block disruption if there is a termination grace period configured.
Yes. Yep, you could do that, but then you would be back to the same problem of if you do that right now, and Karpenter's just going to ignore that annotation and then just like directly tell the pod to evict it, which is not going to be protected because it has no PDB because it's a job pod.
Yeah, I think Jonathan and I had discussed this, I think offline, and I don't remember if I brought it up in the issue. If we were to go that path, I think you would consider the do not disrupt pods blocking until the very end, until it's.
But if there is a way to basically prevent scheduling on the node once disruption's initiated, and then wait until the termination grace period to actually evict that job pod, then yeah, I think that makes sense.
Yeah, and I think we already do have that with the do not disrupt taint, do we not? Or not do not disrupt taint.
The annotation?
No, I'm blanking on the name of it. The taint that we apply.
Oh, okay. Yeah, there's a disruption taint. Yeah.
Yeah, that there is a little bit of raciness with that, particularly with consolidation. I know you're aware. But that is the intention of that, is to ensure once the disruption does begin, no other pods can schedule. The do not disrupt pods will be able to live for the duration of termination grace period and then be deleted at the end. Through the logic you already have.
Yes. Yep, I think that makes sense. Yeah, and back to Jonathan's point, if we did have like an extra like duration that was like wait this long before beginning disruption, I would just set that to 0 and then just use the termination grace period instead, effectively. Just because like I don't really see the point in like delaying the initiation of disruption.
No, I think the argument we had internally was maybe give time for pods to gracefully finish to keep your cluster utilization as high as possible, for as long as possible for cost savings. I don't think there's really any real indication there is demand for that. The only other reason I think you would want separate grace periods is if you want to begin the disruption immediately, but don't want to have termination grace period and
Right.
basically only let pods exit gracefully and just live with the fact that you could potentially have pods in a partially drained state indefinitely.
I see. So this would basically be a delay from when disruption is initiated. So once it starts, the node becomes unschedulable, and then that configurable time expires, and then disruption starts, and then the termination grace period begins the countdown.
Yeah,
is
we
what you-
were.
yeah.
I'm not sure if the node should become non-schedulable at that point.
What's
Just
the
because,
difference then? Because new stuff could get scheduled to it, and then
well,
yeah, I guess
so
yeah.
in today's state, right? If you have do not disrupt pods, we will not begin to even consider that node for disruption until those pods are off.
I see.
This would be a timeout from basically the time that the node is expired or drifted.
Yep.
How much longer after that before we ignore the presence of do not disrupt pods, blocking PDBs, etc.,
Okay.
and start the node?
How is that different than like the expire before option that's been kind of thrown around a little bit?
Expired before.
So if there's already expire after, meaning that the node just dies after this amount of time, and then expire before would effectively be do not disrupt this node before it's been alive for this amount of time.
You mean like min age or?
Yeah, basically.
Okay.
Yeah.
I think it does solve a very similar problem.
Okay.
Yeah, it's a different way of basically solving the same problem. I think it's a little bit more holistic in that it's not just exploring do not disrupt.
Mhm.
It also applies to blocking PDBs
Yep.
and any other reason we may not consider a node a candidate. Blocking PDBs and do not disrupt being the only practical reasons, I think.
Okay. Yeah. Overall, what I'm hearing is that there's desire to help solve the do not disrupt issues that exist currently to support this termination grace period use case, which is good. I'm happy to hear that there's a desire to improve things around that annotation in particular. So, but I'm also not hearing that there's any reason to doubt that this PR has problems or anything. It seems compatible with everything that we're also talking about.
Yeah, I think my only ask is that we would maybe expand the scope a little bit, or at least minimally like make sure that we have the API exactly how we want it, which I think we've talked about before. I think the idea is that we wouldn't have separate grace periods long term. So we'd probably just call this disruption grace period, like disruption.grace period. And then that would be the mechanism by which you would set the overall grace period for like the entire disruption flow, which also includes the termination flow.
Okay.
I mean, so it's hard to do it for the entire disruption flow. Are you talking from like expiration, like the point that a node is expired until the point that the node is terminated?
Yes.
I think node disruption budgets really throw a bit of a wrench in that, at least in my mind.
I guess it's true. That's one thing. Did we consider that as part of I guess we didn't consider that as part of the RFC for this design.
Yeah, I mean, for this design, it starts after the disruption budget. So for termination grace period by itself, it's not really important. But when I was thinking about this holistically, and one of the reasons we've discussed this at length offline, but one of the reasons I came to separate grace periods instead of trying to do like a mix of grace periods was you do have this unbounded time set by disruption grace period. And I think especially given that you've got Bryce's work on disruption controls by reason, it's very reasonable to always respect that. We shouldn't, if you don't want disruption budgets and you want to ensure you always immediately start disrupting expired or drifted nodes, you can set your expiration or drift budget to fully unblocking.
Okay. I generally agree with what you said. I'm not sure how it relates to this particular PR.
I don't think it does.
Okay,
I think
cool.
it more relates to how you might expand it further down the road.
Yeah, I think that makes sense. And despite all the cool things I think that like the disruption controls, and I'm happy to see them come in general, like our stance is that we do not want to be controlling disruption like by the time of day or anything like that, because it leads to confusion usually from our internal stuff. But I can see why somebody would want that as well. So yeah, so we would primarily be relying on just the hard termination once termination has been initiated, that it's going to happen after a certain point. So, and being able to reliably initiate that termination.
Yeah.
As in not being blocked by eviction, but by PDBs or annotations. So.
Okay, yeah. I don't think, Jonathan, I see you just unmuted.
Yeah, I think my only other question is if like your use case here is probably like, I know we have to take into account pod disruption or no disruption budgets only because like that is.
Oh, no disruption makes perfect sense. Yeah.
Yeah. So I think, well, with the schedule, right? So like, let's imagine we have like a 7-day expiry on the node, and then we have like a termination grace. Like your intention behind setting termination grace period is basically, I want this node to go away after 7 plus some number of days or whatever the number is. So you want the node to be terminated after 10 days. You set like 7 days for your graceful and then 3 days for your termination.
Ultimately, yes, we're trying to guarantee that a node will be cycled within like a 30-day window. But we're okay with understanding that the complete sum of configuration, like if we set our node disruption constraints to where it can only roll 1 node per day and we have 50 nodes, then obviously we're not going to be able to roll all 50 nodes within a 30-day window. Like we're okay with understanding that there are limitations there that we could burn ourselves with if we misconfigure them. So, if that makes sense.
Yeah, so you effectively like, you don't want that to represent your max node lifetime. You want it to represent the actual amount of time that you get the termination happening.
Yeah.
Is there a particular reason why you're just wanting to make sure that you don't get like force terminated like immediately as soon as the node goes, like because you're like way past your max node lifetime or something like that?
What I would say is that we think it's more dangerous to do the alternative of looking at it like the kind of like the holistic view that you're trying to propose, because that could result in really unintended side effects. If you say that like, okay, I want every node to live no more than 80 or 30 days, and then that trumps your node disruption budgets, then you could have a case where half the cluster gets destroyed in order to satisfy that 30-day requirement. So I think from my point of view, we prefer simple mechanisms that are well understood and don't try to be too smart, basically.
Yeah, I agree. I was just making sure that was like paper on your side.
Yeah, and the other thing is I think we're just used to working with it from coming from Cappy.
Okay, anyone else have any input to give before we move on to the community questions? Alrighty. So not too much today. So decoupling the release version for the upstream project and the provider versions. I don't know if anyone wants to start the discussion here.
Yeah, I added this, and it was mainly just to like raise for anyone that's developing cloud providers. Like I assume, actually, I don't know what y'all are doing right now, Bryce, for versioning for Azure. Like, are y'all versioning in the same way that we version upstream, or are you versioning like with your own similar versioning scheme that is completely decoupled already?
We're already kind of completely decoupled. I mean, we're like on 0.4, but it may be something we want to reevaluate once we start to promote the self-hosted options a bit more. So currently, like the easiest way to use Karpenter is through NAP and our managed add-on. But we do have, like Alex has been working on some Helm chart stuff so that people can deploy it themselves and things like that. Then the versioning scheme may matter a bit more strictly. But right now we started on 0.1 and have been moving up with every big release. We just bump it up.
Yeah. I think this is mainly
kind of decoupled. I'd be more interested in like release schedule style stuff. So like you know, when we're gonna release big changes, like I don't know, the spot on spot consolidation, things like this. Like we upgrade our providers every 3 months or something like that. That would be interesting to me, is just knowing when these core versions are gonna come out. How do you feel about that?
I think the main point I was going to raise is that, I mean, we're coupled on the AWS side, but some of that is historical. Like as soon as we like separated out the repos, we just kept the versions together because we didn't have other providers. I think 1.0 kind of brings a nice opportunity for us to decouple these things, because up to this point we've just been coupling, and I think just to make it simpler for us to reason about, we kept it that way.
Mhm.
But I think we want to start signaling in the same way that like upstream packages signal breaking changes, and any change that like should cause a provider to have to make like significant changes to the way that it implements things. Want to get out of this habit of like just kind of arbitrarily like not thinking too much about the upstream package, just because like we've coupled the upstream package to the downstream package.
Mhm.
Yep.
Which
And
I think makes a lot of sense in my mind, but
yeah, we're gonna stay decoupled from the Azure provider side. There's no reason to do that. And so I understand the historical reasons for AWS. But I think what you're saying also is that you don't see a good reason to mention the version of what used to be known as Karpenter core, because at some point we're contemplating, using the semantic version last segment, kind of the info segment, to just indicate which version of core it's consuming. But it sounds like you'd rather not have this visible either, right?
yeah, I think we just want to signal to people like when we are actually making the break. I mean, this is kind of just like an addendum, and I just want to make sure that, I mean, I don't see a reason why anyone would have like a major issue with this. I think this is in general like an improvement and helpful, not a worse thing.
Mhm.
Just for y'all, like from y'all's side and also from Amiko's side for Cappy, like as these providers expand out and continue to develop, like not everyone is always involved in all the changes that go in, and therefore it makes it difficult to reason about if there's a breaking change or not on a given version when you upgrade. So I think we need to start getting in the habit of signaling that changes are may cause you to have to make significant changes to your cloud provider. I don't think there will be like a massive amount of significant changes, but if there's any interface changes, I would assume and presume that we would signal that through our SymVer scheme.
Yep. I mean, you already have a really good scheme for like in the release notes, right? The customer visible changes. Doing something similar towards cloud providers would be great, but so far it hasn't been too bad. So
Mhm.
Yeah.
I got one more question regarding versions, as long as we're on the subject. I noticed that you decided to drop the V because the V prefix doesn't make a really like a semantic version. I'm curious if there was something driving this specifically. Like if you're using something that you actually use a semantic version that drove this change.
Flux and Helm both had issues. And Flux had issues because Helm like requires it basically. So Helm, if you do like a Helm list on the repo with an OCI repo, you can't tag, like if you tag it with a non-semantic version with a V prefix, it literally can't, or it refuses to filter out and sort them from latest to oldest based on the semantic version. So by dropping the prefix, you allow Helm to use it, and then you also unblock customers that are using Flux that are trying to do like the regex style like pattern matching that Flux supports for Helm releases.
Okay, got it. So Helm was the driving factor here. And does it only apply to the Helm repo served from the like GitHub repo? Because we're planning kind of shipping Helm charts just in OCR artifacts, and that's it.
So I think I don't think that Helm repos, like actual Helm repos, allow you to even do a non-semantic version. Maybe I'm wrong on that, but OCI certainly does, because you can do arbitrary tags, and so we'd kind of done that, and then as a result, we got burned by the fact that like Helm, when it tries to discover OCI, just doesn't understand or refuses to understand the like dropping the V prefix and just understand the rest of the tag as a semantic version.
Okay, makes sense. Thank you.
So I wanted to add a couple of comments on the release versioning thing too. Like, I think it'd be really cool if once we go to 1.0, if there are going to be changes coming from, Karpenter that are like breaking for a provider, I would expect we lean into the SemVer Like, if it's a major breaking change, we increase the major, version number so people know. I would hope that's the direction we're going to go if we're going to kind of lean into the SEM versioning being a signal of like where you are in terms of compatibility. But then also from the cluster API provider side, like I think we're going to have to release our versions like completely separately because there's like two projects that we're going to be trying to indicate like where we're at with like Karpenter and cluster API. So I think for us, we're probably just going to have to take a completely separate versioning scheme. Like we'll just have to go our own way, basically.
Doesn't major versions create major versions creates a major problem? I think like with Go packages, maybe I'm need to familiarize myself a little bit better, but I thought when you bump the major version on Go packages, you therefore had to like do something special with how you like the directory you stored things in, or stored in a different branch or something. I forget exactly what it is.
If you're using version packages like that, yeah, you can do that. I don't think you have to do that though.
Gotcha.
It's like if you want to maintain the two, if you want to maintain the two separate, if you want to have both versions maintained at the same time and allow both of like Klog and Klog v2, those were like both maintained at the same time. But like if we got to the point where we said, all right, we're at 1.x, the next change we want to put in is going to break everybody. So we want to go to 2.x, but like we're not going to maintain a separate 1.x branch. There might be a tag at 1.x where before we went to 2.x, where we could bring like security fixes on for like a Z-stream patch on that 1.x if anyone was still using it. But new development would be happening on the 2.x series, right? So we wouldn't change the directory structure inside of the module because it would, we're not trying to have both versions be available at the same time, if that makes sense.
Yeah. Yeah, I was just questioning it only because like not that Kubernetes is like the best example of abiding by SymVer. Just think about like things like most of the client Go packages and things like that obviously just track with effectively with the minor version of Kubernetes and then obviously patch as they need. Control runtime maybe is a better example where control runtime has its own versioning scheme that is, I think, actually I'm not as familiar with if it actually tracks directly with the minor version of Kubernetes.
It does not. Yeah, it does not.
Well, the version itself doesn't, but I think the minor version is bumped when the Kubernetes client version goes up, if I remember correctly.
Yeah, that could be, but it's not on the same number because I think controller runtime's at like 0.16 or 0.17.
Yeah, it's definitely not the same number. I was just thinking because they make breaking changes within the minor versions.
Yeah,
and
for sure.
question with whether we would want to do the same thing or whether we want to just fully enforce major version upgrades.
Yeah, for sure. I mean, if the community is cool with doing minor updates and having breaking changes between minor version upgrades, like, that's up to the community, right? It's frustrating to see us move so far from like what the SEMVer was supposed to indicate. And we have these like breaking changes happening on minor revs. And then it's like, you never know what's happening, right?
This is sort of tangential, but one thing I just want to mention that's nice about Karpenter being separate, where the provider core is separate from the core packages, right? So you have the cloud provider and you have core. With Cluster Autoscaler, historically, like if I make a breaking change, I then have to fix it for all the different things, right? But one of the nice things about this provider model is like I don't have to take Jonathan's breaking change in V35 right away. I can just sort of wait to upgrade. It doesn't force everyone onto the new changes and the new versions. So I think already my upgrading to a new version is already sort of at the decision of the cloud provider. So just providing the information there, like of what's breaking, is more than enough in most cases for us. Like you just, we see it pretty clearly. Like, okay, we need min values because they changed the field from using node selector to node selector min values. Oh, there's this get GK or GVK object, etc. Like it's pretty transparent, I think, with the current way things work. SemVar is more interesting on like the provider side. So like I want to tell my users about these changes and breaking things, but maybe I don't know. I have mixed opinions.
I mean, this is not like, you know, an easy or simple topic. There's a lot of different ways to look at it. So, I mean, I think probably from a community perspective, we just have to look at whatever, you know, works the best for our community. And that's like between the Karpenter core and the providers who are consuming it. If the providers are happy with minor version updates, having breaking changes, like, then okay, then that works for this community.
Jonathan, maybe one more thing, as long as we're talking about like the contract between providers and the core. Just wanted to point out that it extends a little bit further than, say, cloud provider API, because we're using some of the global variables to customize, bits and pieces of functionality within the core. Prior to V1, it might be good to like maybe catalog them and collect them and just make sure that everybody's aware of the customization used by the provider of certain things in the core. And maybe even extend it in a couple of places. I think we have a couple of use cases for a bit extra we could discuss.
Yeah, I had the exact same thought. Like, I think maybe the mechanism by which we upgrade and signal breaking changes is maybe a little bit like it's literally semantic. It's maybe like less material than in reality, like what defines a breaking change. Like whether we choose to indicate breaking changes at the minor version level or the major version level, we just need to define like what amounts to a breaking change. And that's something where I know that like you said, it's not just the cloud provider API. It goes to like calls like to new controllers where you like initialize all the controllers and the controllers have certain like a certain signature to them. And if we decide to like change the signature of that function, that represents a breaking change from the cloud provider side or global variables or anything like that. So, and some of them are more transparent than others. But yeah, I agree. I think when we decide to like as part of like thinking about the V1 milestone, I think we're thinking a lot about like, and I'd love to get more like feedback from the community. I think there's an issue on this as well. Around like what exactly like cataloging the things that are breaking changes and then also deciding on like the mechanism by which we signal breaking changes, whether that's a minor version bump or a major version bump.
I think Alex had a really great point in there too, which is like kind of the distinction between API changes or changes that a user of Karpenter might expect to encounter versus, like internal changes that only the provider devs would be aware of. Like, I think that's, hopefully as we get to 1.0, the external API will be pretty well solidified, but I think it's important to think about things like if we're going to revision the API in the future, then like, the notion of like, do we provide conversion tools and whatnot, those kind of things. Just being aware of that's probably good as we go into this.
All right. I think unless anyone else has anything to add, we've got a little bit more time if someone wants to start a new topic or continue this one, but otherwise that's it for our agenda.
Yeah, I would like to bring up one other little thing. I don't know how much needs to be discussed here or whatnot, but something I was looking into and kind of just at the start of it, I'm not sure exactly how it could line up or align with Karpenter exactly, but just from like the Azure side of things, like AKS, we have this like functionality called soak during our like upgrades and stuff like that of like Kubernetes upgrades or other things like that, which is a like time delay between the different like nodes that get upgraded, and then it allows the customers to like monitor their workloads and like see if there needs to be any like actions that they need to take, like see how it's doing on the new kind of set of framework and stuff like that, and potentially like cancel their upgrade or do other things like that. And for the like Azure provider, we end up having basically like this done through the drift model, not the soak, not implemented, but like K8s upgrade or like other similar things like that done through the drift model. And I was trying to like see if a similar sort of thing could be done kind of within the Karpenter framework. But I think that if it was, we'd probably need something within the upstream like change to be able to make something configurable within Drift. But I'm also not sure how applicable it is without like some sort of cancellation or other thing, and wouldn't want to impact other Drift behaviors. So I kind of wanted to basically bring it up here as something that's like kind of exploring and seeing what a similar sort of like feature or whatnot, sort of like monitoring for the customer of like these new sort of like capabilities, specifically like Kate's version or other changes like that kind of coming on, and kind of actionable stuff or like giving the customer that sort of window. And if there might be some way to integrate or like create some sort of like framework like that within Karpenter, and then also like make sure that it's like actually something that could be valuable within like actionable by like a customer, for example. So that's something that I'm starting to look at. I was planning on opening, like doing a bit more looking into it and opening like an issue on it to kind of get discussing, but wanted to also surface it here just so like people are aware, or if anyone like has any initial thoughts. I'm very in the beginning stages of like looking at the idea of something like that.
So, from my own understanding, would this basically be like a rolling drift window where you kind of continuously increase the set of nodes that are affected by drift and potentially back off if there's failures?
Yeah, so the exact like implementation of like how you want to approach on like failures or other stuff is part of the thing that I'm wondering like how exactly to make use case of this. So like in the like AKS side of things, we have like batches of nodes. This is non-Karpenter related, like just regular Kubernetes, like batches of nodes that get upgraded. And then we have like a customer configurable like basically window to like pause in between and like let the workload settle and let kind of like see how things are operating or whatnot is something that they can kind of configure there. And then if there's like bad signals or other stuff, like if they detect like issues, they can cancel their upgrade and then be like, we actually don't want to be progressing forward with this. Like we found some sort of issue. And so like basically wondering how basically like within the batches or whatnot, like within like Drift, like whether it's depending upon like your budget size or other stuff like that. Like if it's just one node and then like a delay and kind of like let customers assess or something like that. That's something that since Drift has a lot of different umbrella things, it's like something that also like not entirely sure on, but yeah. Yeah, as Bryce is pointing out,
I was just
chat.
mentioning what the node soak feature is. I mean, we
Yes.
have to support quite a few of these upgrade functionalities, so maintenance windows, these sorts of behaviors. And I'd love if Karpenter could be a place where we can also support like some better, smarter node image upgrade and various upgrade strategies, right? And we can share them maybe, and AWS can benefit from that work as well. Because we need to support it regardless for our product's quality and meeting the AKS bar. So hopefully we can come up with a way where we can collaborate and drive this functionality maybe into core, and then we can discuss what the best upgrade strategies are and things like that. Charlie mentioned he's going to open an issue, but I just want to give some context. Like we need to support the ones I listed publicly. We need to support them in some way, I think, for our requirements. Alex can correct me if I'm wrong, but I think at some point we have to.
Yeah, thanks for sharing that over, Bryce. Yeah, I think that's like mostly it. Mostly just to like starting exploring there. I'll open up an issue on it to get some more conversation there and stuff like that too.
Yeah, look forward to seeing it. It definitely seems interesting.
Sounds good.
All
All
right.
right. So we're at time. And thank you all for coming.
Roasting.
Thank you.
Thanks,
Thanks.
everyone.
Thanks.